to the first session of the Spring BITS Open Research Seminar. We're delighted that you could join us today. If you're new to BITS, we were established in 2012 to improve the credibility of science by advancing transparency, reproducibility, rigor, and ethics in research. We do this by generating evidence about problems and solutions in science through meta-research led by BITS investigators. We do this through increasing access to open science education through seminars, workshops such as this one, and our flagship research transparency and reproducibility training. This year that will be held in Berkeley in person from May 17th to 19th, and you can check out our website to see more details about the event as well as how to apply to attend. And the third pillar is we strengthen the scientific ecosystem by developing open science policies, protocols, and platforms that enable open science at scale. The BITS Open Research Seminar was generously supported by the Templeton World Charity Foundation. And this is a continuation of a webinar series that we started last fall to promote and share knowledge about the use of tools and practices for transparency and reproducibility in social science research. This spring, we have 4 sessions scheduled. Today's session on reproducible analysis of tax and benefit policy. On April 6th, we have a session covering topics in research ethics and best practices, featuring speakers from 3IE and the University of Oregon. On April 20th, we have a session on building student-led reproducible research, featuring speakers from the University of Arizona. And then finally, on May 2nd, we have a presentation on launching the MCC evidence platform, why usable evidence tools are critical for impact, led by the MCC team. So please see our website for more event details about the Open Research Seminar this spring, as well as signing up for our BITS newsletter so you can be in touch with all of our upcoming events this spring. Please make sure you follow us on Twitter as well at UCBITS, as we share a lot of these events and details through our Twitter. And we're just so excited that you're joining us here today. Thank you to those who submitted proposals. We received very interesting ones from researchers, practitioners, and students all around the world. And we're just grateful to be working with all of you today and are excited for this session. So now my colleague, Fernando Hosas, the BITS project scientist, will introduce today's speaker.
Hello, everybody. It is my pleasure to introduce Max Ghenis. He is the co-founder and CEO of PolicyEngine and the founder and president of the UBI Center. Previously, he was a data scientist at Google, and he holds a BA in operations research from UC Berkeley and an MS in development economics from MIT. Very excited to hear Max talks today and the advances that he's making in the space of bringing transparency to policy analysis. Max.
Thank you, Fernando. Thank you, Grace. Thank you all for joining me today. And I'm really looking forward to sharing some of our progress on tax and benefit policy and transparency, and get your feedback on sort of our approach, which I will get through you via an actual interactive tutorial. So if you're at a keyboard, this will be even more engaging, I hope, because we're going to see the app in action. We're going to do some Python, basically copying some of the code that we use to reproduce our results and give you more flexibility and transparency. But with that, I'll sort of start with sharing my screen. Yeah, so PolicyEngine is an open source model for tax and benefit microsimulation analysis. And it's a project that we started out of a think tank about 3 years ago now. So we were expanding our think tank, the UBI Center, from the US to the UK. And there was really great open source tax modeling in the US. We didn't have that available in the UK. So we built it to help us do our own policy research there. And then we sort of threw a front end on it. And then we realized this was relevant beyond just the scope of our think tank. So we released as a separate independent nonprofit. And now we're also in the US, we're building out Canada, and we even have a basic Nigeria model. So I'll sort of focus this presentation on what's happening in the US, but pretty much everything I'll talk about is also relevant, certainly in the UK, which is our most developed model, and to some degree also in Canada and Nigeria. So I'll start with the problem and landscape, just of why tax and benefit policy is important, and why microsimulation can help give some clarity around those topics. A bit about us at PolicyEngine, transparency in this field of microsimulation, which I think is a very powerful tool for policy analysis. And then we'll sort of jump to the demo and tutorial. So I'll show how the PolicyEngine works, both on the individual household side and the population impact side. And sort of interspersed within that, we'll see how to reproduce some of those results in Python. And toward the end, then I'll sort of give a quick tour of the code, the way that everything we organize on GitHub, everything from the microsimulation model all the way to the interface itself is open source on GitHub. And a little bit about how we're thinking about a more transparent future in microsimulation modeling. And please feel free to drop any questions. I think I can see the chat. So great. Okay, so as I'm sure many of us know here, taxes and benefits are an enormous part of the economy. Developed countries collect about 1/3 of GDP in taxes, and they spend about 1/3 of that in cash benefits, the sort of cash benefits that microsimulation models tend to quantify. And those numbers are both rising, so up from about 1/4 in 1960. And as developing countries get richer, all the past trends indicate that they are also going to increase the amount of tax collection, redistribution, all of that happens through the government. So there's a lot of opportunity to help governments make more informed evidence-based decisions around this enormous part of the economy. And there's a lot of stakeholders, of course, that care about this, everyone from voters and households, taxpayers, people who receive benefits, everyone in society, really, this affects in some way. And all the institutions that help people understand how those policies work and policymakers themselves. But we've really seen that there's room for improvement in terms of a shared evidence-based discussion around that. So especially connecting these policies from the individual impact all the way up to the macro impact, and helping everyone from individuals exploring the policies to policymakers actually defining them, having that all have a consistent quantitative lens. And the ecosystem is pretty subpar in our view when it comes to transparency, for sure. So in the UK and Europe, there are a variety of Windows applications that let you do some kind of microsimulation modeling for taxes. Lots of completely closed applications, whether those are those used within governments or within think tanks. Sometimes if you're trying to estimate what benefits you might be eligible for, there might be some tools available depending on, for example, the state. This is actually from Oregon, but really just tells you if you're eligible or not how much you get. And it's not mobile friendly, and it doesn't really tell you the whole scope of the taxes and benefits that apply to you. There is some progress on taxes. So there's a tool called Tax Calculator from the Policy Simulation Library in the US, but it doesn't have benefits, doesn't have state taxes. And in many cases, really, for a lot of policy questions, there just are no tools for open source policy analysis. So that's where we come in. Our mission is to compute the impact of public policy for the world. So we're trying to build a microsimulation-based framework, a rules engine that can power a wide variety of questions for an infinite number of types of users. So people in the US from all levels of policy fluency, and our mission is really at some point to expand globally. So what that means is, from our perspective, we're basically building a microsimulation model, a rules engine that starts with some of the core concepts, core fundamentals. So usually you have a survey microdata set. You might compare that to administrative totals as well to get more accurate results of that microdata. You then have legislation, or sometimes, especially when it comes to benefit programs, those are actually defined in administrative law, or you have to go to government websites to just see what the rules are through program handbooks. So we use whatever data set we can to get as precise rules as we can. And we've benefited a lot from OpenFisca, which is a microsimulation framework developed by the French government and now in use across the world. We've since sort of forked it into our own version of the code to satisfy our needs a little bit more. But it's really been a foundational tool that we're grateful for. At that point, so those are the core ingredients, then we turn those into our own microsimulation models. So as I mentioned, those apply in the US, UK, Canada, and Nigeria at this point. We're also probably going to expand to Australia and New Zealand shortly. And then the enhanced microdata we've done on the UK side. So we do some data fusion, basically integrating different data sources, as well as reweighting using gradient descent. So some sort of these more modern machine learning or data science kind of tools have helped demonstrably improve the accuracy of our model. And we're working on that in the US as well. And then I think we are able to wrap all this together. So we have Python packages that represent these pieces of the equation, but we also have a front end, so a open source web interface to explore these policy concepts and reforms. Once we have it, we can answer a variety of questions. So simple questions from how much food stamps I be eligible for as an individual household, or intricate reforms. So we can actually say we've worked with the UK Green Party or sort of helped analyze their policies for some of their events. And this is a very complicated policy reform that they released in 2019. Lots of different tax reforms in terms of adjusting existing levers through the income tax and national insurance, which is kind of like payroll tax system, but also changing benefits, introducing a land value tax and a carbon tax, and a UBI, universal basic income. So because we have a comprehensive model that captures all the interactions between these policies, we're able to accurately model all of those together. And so we serve this on a wide variety of devices as well. So everything from mobile to desktop, you can sort of define your household, define the policy reform, see the impact of a policy reform on society or an individual household. So we just launched a new version of our interface earlier this year, which works a lot better on mobile. So I'm going to talk a little about transparency in microsimulation. And just to recap sort of what microsimulation is, it's basically a tool that combines two parts. We have a rules engine. So that's saying, given a set of characteristics about a household, what, in our case, taxes might they owe, what benefits might they be eligible for. It's used in lots of other contexts too, like health, figuring out what health insurance, or even what health outcomes potentially, if you want to do probabilistic models of contagion and all those kind of things. That's all doable with microsim. And then the other side of it is pairing it with survey data so that you can basically run that rules engine over multiple households, aggregate the impact, and you can do that in multiple policy scenarios. So it's just as one example, suppose there's a household with 100,000 gross income, no kids. You might find that this rules engine would say there's a tax liability of $30,000. So they have a 70,000 net income. You sort of apply that the same way across multiple households that has different amounts of net income. And each of these survey records has a weight. So this is basically the number of households that is expected to represent in all society. You can then aggregate that up to figure out the total tax liability under policy scenario, total benefits, total net income. And you can sort of do that for multiple policy scenarios to compare at an individual level, things like distributional impacts, but also budgetary impacts and incentive impacts as well. And this is used for a lot of different studies of taxes and benefits. So for example, the Trump tax cuts, there was a really cool interactive visualization that the New York Times built. Washington Post had similar visualization. These were actually using the open source tax model that came out of the policy simulation library. And same thing in the UK, you often see these decile breakdown charts. Those are all pretty much the result of microsimulation models. And you can break down not just by income category, but break down the impact of policy reforms by other demographic characteristics, really any demographics or other characteristics that are in the data set. And we this is not exactly a spectrum, but I think we try to think of how we bring transparency to this realm by thinking of a few different stages and milestones. So publishing reports is the typical way that microsimulation models work. You really just have a specific analysis for a specific policy reform, and you might just publish that report and have some aggregate results of some microsimulation model that might be in the back end. There are some models that go a little bit beyond that in terms of publishing aggregates. So UKMod is one example of this, where you can actually see, this is in the UK, a microsimulation model that tells you, here's the total amount of universal credit or income tax that we get from our model. And that lets you compare those against other types of models. So it's been very helpful for us to benchmark our progress as we've made our model more accurate. And then you can go further and make the model public. So make the rules public, ideally the data public, although sometimes there are restricted data sets that you can't make public in full, but you could make public the code that generates the microdata from the most raw sources. So that's what we do in the UK. We have all the code that goes into the rules are all on GitHub. And in that same repository, we have all the data processing. So unfortunately, the UK, unlike the US, does not allow sharing that data. But anyone with access to the data could just run our Python code over it to get the same results that we did. And then making it all open source. So I guess these two were kind of very similar, but doing it not just in terms of you get a zip file of your code at the end and then sort of publish it on a website. We're actually going further than that by having open source be the way that we develop it. So we don't have any private code ever. It's purely you have the model, and every time you want to make a change, we're filing an issue on GitHub. We're then we're filing a public pull request, which means sort of a request to change the code. And anyone can see the steps that we're taking to make progress on our development. So I think this offers people insight into what the things we're working on, what's coming up, and also if they see an issue, they can just file that as an issue so anyone can see if we have to fix it in the future. And then the final step that we take is having an interactive app that allows anyone to access it. This isn't purely a research coding transparency kind of step, but it does get more eyes on the same product. And we've seen that as we have more users, we've been able to identify issues or opportunities to make our model more accurate, more representative, and ultimately produce more informative, more relevant policy analysis. And we also make our app open source as well. So comparing us to some other models, we're, I think, unique in our transparency and our comprehensiveness. So there are a variety of other institutions that build different tax or benefit microsimulation models. We're the only ones that let you both model reform impact, model the impact of federal and state taxes and benefit programs. And this is pretty important because all these programs actually connect to each other in many ways. So certainly state and federal taxes, you have the state and local tax deduction. Some states also offer a reduction in your state taxable income based on how much you pay in federal taxes. So, and even some state tax programs are based on the amount of benefits you get. So amount of like food stamp benefits, for example. So having this all in one model lets you capture all of those dynamics appropriately. And then we have an open source app and open source model. With that, I will turn over to the demo. So you're welcome to follow along. At some point, I will share a Colab notebook, a Google Colab notebook that has some sort of outline of what we're going to do in terms of the results of the app and turning that into code. So here's PolicyEngine. We're looking at the US model here. And we really have two different entry points into the same underlying rules engine. So one is for people who are just looking to understand how current tax and benefit policy affects them. And the second is for sort of the policy wonks. So these do come into play together at some point. The policy wonk side, that's really the core output we show is the impact on the budget, inequality, poverty, sort of macro level impacts. But you can also use it after you've defined your household to say, what is the impact of this policy reform going to be on my household itself? So useful to see, I think, both sides of it. I'll start with the household side. So we start with a 5-question questionnaire just to get the basic information that we need to provide useful results. So those questions are marital status. So let's say maybe we're a single parent, maybe with 2 kids, and we require state. So we actually just launched California. So in honor of bits, I will select California here. And employment income. So that's just wages. Let's say maybe they're right around the poverty line, $20,000. And then ages. So let's say maybe the parent's 40 and maybe one of the kids is 5. There's 10. Okay, so I think the first step that we try to take in terms of transparency is we're telling people what we're calculating. So there's lots of tax and benefit programs you could calculate. We do not calculate everything in California yet. So childcare subsidies, for example, we're pretty close on some electricity subsidies, but we don't quite have those yet. But we have some of the most important ones, I think. So income taxes, supplemental security income, SNAP, food stamps, broadband subsidies, and this is the part that we just added recently, state income tax, as well as TANF benefits, which is kind of like a cash welfare program. Okay, and then this is really the crux of the result that we show is net income. So net income is how much you earn or how much you get from the market income, plus benefits, plus refundable tax credits, which are effectively benefits paid out through the tax system, minus taxes. So we can expand each of these to see in more detail what they are eligible for and taxes that they owe. So they're getting SNAP and also free school meals. So these are all dependent on their income, and we can actually drill in more. So SNAP is partially sort of the standard allotment that's been in existence for several years, but also throughout the pandemic, there's been an emergency allotment, and that actually ended, well, in March. So we do model 3 months of that in accordance with us modeling the full 2023 year. In terms of refundable tax credits, this household would receive $9,000 from federal. So EITC, they get $6,600. And then the CTC, the child tax credit, is actually kind of a combination of 2 programs. One is a refundable credit, the other is non-refundable. So we show the refundable separately here. And also California, they get a certain amount from California's CITC, $420 there, and about $1,100 from the Young Child Tax Credit. Okay, and finally, they would pay payroll tax. They would not have enough income to pay normal federal income tax or state income tax, but they would if they earned more. And now it gets progressively wonkier from here. So now we're going to vary their earnings. So we're going to say, that was just one scenario. What happens if we change the amount that they earn? How does that affect net income? Okay, so that's this chart. Usually you want, this to go up and to the right, and it mostly does. But this is the thing I think that we see from being able to model taxes and benefits together. You often have these welfare cliffs. And it's not obvious how you would fix those. I'll sort of talk about that a little bit later. But so for example, because I've spent enough time looking at these charts, I can tell you that this is TANF. This is a clip from TANF. This is from SNAP, and this is from reduced price school meals. So as net income, it rises pretty quickly at the bottom. So a lot of these programs actually phase in, for example, the tax credits. So you have effectively negative marginal tax rates, which we'll see in a moment. But after that, you can sort of zoom in here. We can kind of see that going from about $12,000 of earnings up to, let's see, $50,000, they're only gaining about $12,000 of net income. So that's roughly a 70% average marginal tax rate over a pretty wide earnings range. So we can drill in and actually look at any of the variables that are in the system. So this is has been very helpful for us to identify and just understand how policies work. So this is funky, okay? SNAP actually has a reverse cliff here, and then it has an actual cliff here. So this would be pretty unintuitive. The reason this happens is because TANF actually counts against your SNAP allotment, or as countable income for SNAP. So we can look at TANF itself and we see, okay, TANF has a cliff. SNAP is sort of filling in part of that cliff. So any of the variables here you can drill into in that way. And all of this is captured in the URL. We'll see this in a moment when we start to model a policy. But you can just save this household ID. So if you want to reproduce this chart, you can do that just by sharing on Twitter or however you need to. Okay, the last piece here before we get into some Python is the marginal tax rate. So at the current level, it's a 17% marginal tax rate. That's here. It's also on the right side here. And you can see the MTR is actually negative in the low end. So you can then, it sort of goes up to infinity at each of the cliffs, and then it progressively rises from there as various credits sort of phase out in different ways. And if you want to do more, sort of look at each of these variables individually, or maybe run through a variety of households scenarios, we offer this page, which lets you reproduce the results in Python. So this is a generated Python snippet, and I'm just going to drop this into the chat so you can see this code. And we'd have to sort of scroll over. It'll be easier in the notebook. But basically, some of the characteristics we entered are just shown as numbers as variables here. So this is all from our PolicyEngine package. You can click the copy link, and actually, I'm going to drop this link too. This is a link to a Colab notebook with some
recording in progress.
And there's a couple steps to running this. So if you want to open up this notebook and follow along, you can just go to File, Save a Copy and Drive, or you can just overwrite it. It won't change mine, but you can sort of change the code and it'll operate within your session and then go away if you close the tab. So however you'd like to do it. I'll just give folks a few seconds to open this up for those who want to follow along. Okay, so there's a few steps. The first step is going to be, if you haven't used a Colab notebook before, this is a web-based Python notebook. So there's a couple parts to Python notebooks in general, or Jupyter notebooks. They can actually be other languages as well. You've got these markdown cells. So you can just type and format your text in that way. And you have code cells. So code cells just operate and you can execute them as if it's a Python script. So here I'm going to do pip install PolicyEngine US. There's quite a few packages in the default Google Colab environment. Maybe someday PolicyEngine will be one of them, but for now we have to install it from pip, which is the core way to install Python packages. Okay, we'll need to really look at the output. And now we've got the household computation. So I just sort of started this notebook off by copying the code that we saw just now. Actually, this might be a slightly different household than what I just did. So I'm just going to delete all this and oops, I will hit copy here. And we're just going to paste this in. Okay, so now we can see this a lot more clearly. And the way that that PolicyEngine structures this is basically a series of dictionaries or JSON structures. So we have, we start off with the people. We have information about each person in the model, and each of the attributes, we're going to say for the year that we care about, what is their value? So, okay, they're 40 in 2023. They have 20,000 income. This is the first person in the model. And then the kids are aged 10 and 5. And then we have to define also structures that contain them. So there are a variety of structures that we have in our model because different tax and benefit programs consider groups of people differently. So we have to model each of those separately. But basically, in each case, it's the same. We have the entity that we care about, the specific entity that we're entering, and the members in that entity. So they have a family, they have a marital unit, and those are all, that's for the SSI program, actually. Tax units, they would file taxes together as dependents. SPM unit is basically a group of people that live together and share resources. So SPM is a supplemental poverty measure. So it's a group of people that the census defines for computing that poverty measure. And a lot of benefit programs basically are counted with those groups together. And then households as well. So we're saying here's the state that we care about. Otherwise, it's the members. Okay, so once we have that big dictionary, we're going to say, here's the simulation we care about. And we're just passing the situation. And now we can calculate the household net income. And if we do this with just the default stuff, this is going to produce a pretty big output, but very, very helpful for understanding intricacies and also just for debugging. You can actually see the entire computation tree. So that's what this line does, print computation log. So every variable that has a number that relates to household net income, you can kind of think of household net income is taxes, benefits, and then each tax, EITC, CTC, sort of going into individual variables there. Maybe SNAP has a countable income concept. So we're sort of seeing all of those together. This is often extremely overwhelming, but it can be very helpful if you know what you're looking for. So for example, California taxable income, 9596, that's what is going to determine their actual tax. And similarly, they get the refundable credits here. This is a little bit more manageable now if we say, and we can sort of close this up. We can say, what's their SNAP? So now we're just looking at one subtree, effectively, of the computation tree. So SNAP is a subset of all of the household net income. It's still pretty big because each state has different rules in some cases, but you can kind of see that, okay, we've got our $20,000 earned income that's showing up in a variety of places. And ultimately we get the 5949. I'm also just going to comment this out so that we can just see that one number by itself. So I'm going to ask you all to do, or those brave enough to go with the Python programming, is to just try adjusting the employment income to some value that you just want to explore, and recompute household net income. So that's probably in the notebook already, but you can, household net income is the name of the variable there. So I'll give you a minute to try that out. And then once you're done, also compute SNAP for this other household. And if you want, you don't have to just adjust employment income. You can adjust any of the ages or, yeah, basically any variable that shows up in the system. So I will take a minute to leave you to that. Feel free to drop questions in the chat or unmute if you'd like to. Yes. Okay. So I got a question to try it with 30K. And I'm going to copy this in there. Actually, I should do this from a copy myself. I'm going to do that. So 30K, I would just sort of adjust this number here. And we will see what the snap is. Do you want to share what your number was? Or I've already hit the go, so I can't be biased anymore.
No, I don't think I modified the snap part. I modified the 30K part. What did you modify for the snap part to make sure that you completed snap?
Calculate. So we're going to change the name of the variable to snap. Yeah. And actually, we don't need to rerun the whole thing. We can just do it here. So 3549 is what I got there. All right. Any questions or otherwise I can move on? Cool. So I think now that's sort of just understanding how policies work today. The exciting part, I think, is also exploring policy reforms. So now go to create a reform. And here we don't have a questionnaire anymore. Actually, I should have mentioned in the household page, those are 5 questions, but you can actually enter any of the hundreds of variables that are in our system. So if you want to explore this household with certain amount of rent that they pay or charitable contributions or the amount that they spend on broadband or childcare, you can do that with our interface. Here, we're leaving it more blue sky because we don't know what researchers will want to explore. So we have all of our policy parameters organized by government agency. And that's everything from states to IRS. And if we want to modify, for example, SNAP rules, that would live in the USDA location. So let's actually try that since we were just looking at SNAP. We can go into SNAP or USDA, SNAP, and let's change the expected contribution. So this is kind of like a marginal tax rate for the SNAP program. It's currently set at 30%. So let's bring that down to maybe 20%. And we can see the history of this parameter over time. So also, I mean, we only go in most cases for a lot of tax programs a year or 2 back. But if you think of, for example, MBER's tax sim, they go back to the 60s or 70s, depending on federal and state taxes. And that's what enables really robust econometric approaches for estimating labor supply responses and those kind of things. So that's definitely on our roadmap. And in the meantime, this policy parameter happens to have been the same, at least since 2005. So we can see that here. Okay, so that's a very simple policy reform. We could also have composite reforms with lots of different parameters. I'm just going to leave this one here as a single parameter for now and go back to calculate my household impact. So in a minute, we'll also see how this affects sort of the more macro indicators. But let's just see how this affects this household. So we're now recomputing this sort of the microsim for an individual household side. And we can see that this would change their benefits by $11.40. And specifically, it's actually reducing the emergency allotment because the emergency allotment is dependent on how much you would normally get. So they're actually going to get more from the normal, which means less for the emergency allotment to fill in. And we can go back here and see if, again, doing that sort of employment scenario analysis, if they earn more or less, how does this affect them? So now we've got 2 charts. You can kind of see the gray and the blue. So the gray is the baseline, blue is the reform. And we've got different kind of cliffs that overlap a bit. Easiest to just look at this as a difference chart here. So again, kind of funky of a chart, but because of the interaction between TANF and SNAP, and also there is a cliff again, so it actually seems to amplify that cliff, which I think if we zoom in, we might be able to see that. Yeah, so here's the SNAP cliff. It's falling to the same level because after the cliff, they get 0 SNAP, but before they lose it, they actually get a larger value from SNAP. Okay. This is not the same, and we'll see this in the code in a minute, not the same as the difference. Actually, sorry, is the same as a SNAP allotment difference. But sometimes you see these charts and it's not just the policy you change because there's some downstream other policy that is responding to that. So if we were changing the TANF, for example, changes to the TANF would not be the same as changes to the net income because SNAP would fill in some of that gap. And we can look at the change to marginal tax rates as well. So in general, as we expect, it sort of lowers marginal tax rates in most of the earnings distribution, except for where it amplifies the cliff. So it's kind of a zero-sum marginal tax rate change. It's just moving MTRs to a different part of the earnings distribution. And now we can go back and we can reproduce this in Python again. So if you go to copy, now what we see is we've got these modify parameters code here. And this is basically taking the parameters that are in the system and we're updating them. So we're updating specifically from 2023-01-01. Whoops, I should have mentioned this. So parameters gov, USDA SNAP, expected contribution. That's the part of our code that we're adjusting. And we're setting the value to 0.2. So if you were to look at that in the baseline, you'd see that 0.3. And now we can change that. Okay, so you can hit copy. I'm going to drop this in the chat as well. Hit copy. And so you can just take what I did there and put it in this next section. And you can redesign the policy and maybe recompute SNAP for this household, whatever household you described before. And you could even try changing the parameter value too. You don't have to just use what was copied.
Max, I think you're muted.
Yeah, I was just giving folks a minute. I will jump back into the code and suggest how I would do this. So yeah, copy here, and now we can go back into the code. We can actually change a bunch of stuff at once, maybe 40,000. I guess we were looking at 30,000 before. And now we go back up here and we're going to change this to 0.2. But the really powerful thing is if we turn off the print computation log, we can sort of run through a loop of different policy scenarios. And it's really just maybe a 3 or 4 line Python loop to figure out how someone's SNAP would be affected by different levels of these parameter values. So that's not something we show in the app today. We only show the earnings variation. So if you want to vary anything else, we just did an analysis on varying how much someone would take home depending on how much they give to charity. So by doing that in Python, and in that case, we use this app called Streamlit, which lets you design a dashboard in a web app very quickly. So having this all, and basically what we did is we started with just doing it for one. We did it in the web app, even though we use the Python quite a bit ourselves, but it's so much easier to start with that, with something in the web interface and then sort of customize it from there. Cool. So from there, now we can finally go to the economic impact. So when we do this, this is, I guess I'm this long into presentation on microsim, and this is the actual first microsim we're doing. So we ran it over about 60,000 households that are in the current population survey March supplement. And that's what allows us to say, okay, oh, I didn't name this, but we could give this a name. Lowering the SNAP expected contribution 30% to 20%. Okay, so now we've got some nice titles that reflect the policy reform. Okay, so this will cost 35 billion according to our model. And we can see all of these impacts here. So by income decile, it's somewhat progressive. Folks in the bottom 4 income deciles would come out ahead more than those at the top. And the reason folks at the very top are still having a non-zero benefit is there are some people who are in households that have multiple SPM units. So you might be in a household where you have a rich person, but then maybe some roommates that are lower income, and the lower income ones might get SNAP. Okay. We can see this in percentage terms. So these are some of the standard reports that CBO would do, for instance. But we do some things that are a bit less standard. So for example, every income decile, what percentage of people in that income decile benefit, and what percentage of them benefit significantly. So this is especially, I think, interesting when you have policy reforms where some parts are revenue raisers, some parts are higher expenditures. You might see that the average impact for an income decile is positive, but some people still come out behind who are in that income decile. So it's sort of a winners and losers chart. So more than half of folks in the bottom decile come out ahead, and only 1% of people in the top decile come out ahead. And then also poverty impacts you tend not to see. So this is the impact on poverty by age, and this is using the supplemental poverty measure, which incorporates taxes and transfers and housing costs and things like that. So this would actually have a smaller impact on deep poverty, which is folks living below half the poverty line. We just added for International Women's Day, poverty impacts for men and women separately. Not much of a difference there in this case. Same thing for deep poverty. And also income inequality. So we show 3 different measures of inequality, the Gini index, and then also the share of income held by the top 10 and 1%. And you can sort of see this makes sense. It's a more broad-based kind of tax benefit reform. It's helping folks largely in the bottom half of the income distribution. So you're going to have a larger impact on measures that consider that broader distribution rather than just the top, like the Gini index. And here's the last one. So we actually estimate the impact on cliffs, and we have to rerun this because it's a little bit, we basically have to do a double simulation. But this is the share of people who, if they were to earn more, they would be worse off. So you can kind of see those cliffs at the individual level in the household chart. This is what lets us actually see the impact overall. So this shows there is some tension between poverty reduction and cliffs in this case. It's actually making the cliffs more prevalent and larger as well. So we show both the impact on the percentage of people who would be subject to cliffs. So that's the cliff rate. And right now we estimate that's roughly 0.5% of people. My guess is it's probably closer to 5%. Once we added more benefit programs and all the state income tax models across the country. Just because they sort of compound, so there's increasing returns to adding more marginal tax rates, more cliffs are going to make cliffs almost exponentially larger. And then the gap is basically in aggregate of those people who are subject to a cliff, how much would they lose from those extra earnings? So, policymakers might consider other ways. If they were considering reforms, there might be other ways to soften that cliff impact while having a similar anti-poverty impact. And very similarly, we can reproduce in Python. I imagine some of you have scrolled your eyes to the bottom left here. So I'm going to come back to the reproduce in Python and just show you this part, which we just added and are having a lot of fun with. So last Friday, we thought, okay, we're passing all of this JSON data into our server, basically computes the impacts that go into each of those charts. And then we're using the Plotly JavaScript library to figure out how to visualize that data. So maybe we can just tell ChatGPT, hey, here's all the data we have for each of these charts. Can you summarize what's going on here? So that's what we did. We basically now generate a ChatGPT prompt, starting with some general stuff like the kind of tone we want, how to format numbers, saying to cite the software. And then we pass each of the JSON snippets. So here's sort of, let's see. Oh, so here's the actual policy reform. But now you're seeing all these numbers here. These are the numbers that would go into each of those charts. Okay. And I guess our data is labeled well enough for it to figure out what those variables are. So lose less than 5%, et cetera. And we tried just putting this into ChatGPT. Later on Friday, we got off the wait list for GPT-4, the API. So now you can actually just hit generate. And this takes about 20, 30 seconds. And then it generates a whole summary of the impact of this policy. So we're exploring various ways to do this more in the future. For example, you could not just have one prompt here, but customize it to the audience. Maybe you have a wonk mode, but explain like I'm 5 mode for high school economics teachers, those kind of things. And certainly people could just copy the prompt into their own ChatGPT session if they want maybe to frame it from an advocacy angle or something like that. They can do that. We're probably not going to do that within the app itself. But yeah, I think it does a really good job. This is my favorite part. It summarizes the policy reform, what's actually going on, in a way that really requires some knowledge of how these programs work. So it's been very impressive. In case you'd like to see this, I'm just going to copy this into a doc. We don't save this to our database yet, so staff. You should. Yeah, so definitely eager to hear all your ideas of how we can use GPT for policy analysis in the future. Okay, so back to here, now we can reproduce the results. And instead of just looking at that household, as we were looking at before, we're using the microsimulation interface to PolicyEngine. And this is what pulls in that current population survey data. And it's going to say, okay, we populate it by a certain number of variables that you might want to compute at the beginning. This actually is kind of slow in Colab, so I'm just going to suggest another way of doing this. And I think I put it in here as well. I basically copied and just replaced the data frame with just microsimulation.calc. So once you have the microsimulation, you're passing in reform. These are all going to return something like NumPy arrays, or Panda series. It's actually a different object that we created called the micro series. So that's going to attach the survey weights to every data set and make it so that when you do stuff like .sum, it automatically calculates the weighted sum. So maybe I'll take a second to run this. And if you're running this for the first time in your browser, it's going to actually download the CPS data from the government website. That's one area where maybe there's an opportunity to be more transparent, so we can say what specific version of the microdata we're using. But yeah, so we've got 39 billion in total SNAP that is changing as a result of the reform. So this will be the last programming exercise, but just sort of give a shot to changing the number. You can copy the cell and just change one of these values and see how it affects SNAP. Or if you're feeling brave, you could try making a for loop and sort of making a chart of how the impact is for different SNAP levels. All right, so I'm actually going to do that. I think I'll be able to do it. So I'm going to make a function for snap change, and that's going to be a function of the expected contribution. And just basically copy everything here. We don't need the imports anymore. And if I just copy in value equals expected contribution, we can then return the value. And now snap change 0.2 should give us that 39 billion we just saw. And while that's going, I can do maybe make this a list for I in range 10. And I think I can just do L plus equals snap change. Oops. I divide by 10. Let's take a look at L. This might take a minute or so to run, but from here, you can very easily create now a chart of how this all looks. And to give you a sense of how we've done this in the past, I think UK personal allowance maybe. Yeah, so we made this chart, which is, okay, depending on the amount of the personal allowance, which is kind of like the standard deduction in the US, what kind of UBI, how much revenue are you generating? And if you just spread that amount across everybody, how much would that be per week? So 12,500, this is the amount that it currently is. So the smaller the allowance is, the more of a transfer you could afford with the budget neutral reform. And then we can also look at how that affects the Gini index. Okay. So similarly, more redistribution is going to produce a smaller Gini index. So these are all very straightforward with the Python interface. That's probably going to go for a bit. So that's too ambitious. I'm going to move over to the last part of the demo here before wrapping up and taking your questions, which is just showing how the code works. So this is github.com/PolicyEngine. And we have a few different repositories. So each of the country models, so US, UK, Canada, Nigeria is also in here. those are the rule sets for each of the countries. So all the rules for taxes and benefits live in there, as well as the processing logic for data, microdata enhancement, and just ingestion. And then we have a repo for the app client, which is in React. And that's been nice to have open source too, because there's been some people who have said, hey, I don't like this way this works in the app. And if they know a little bit of React, they can just file the issue, fix it themselves. So it's been very valuable to us. And then the API. So our API is serving our app, but it also serves a couple of other apps. So anyone, if they want to figure out tax and benefit rules, but maybe they don't want to run their own Python server, they can just hook into our REST API and sort of ensure that those rules are available to anyone wherever they might be. And then the core simulation framework, which is adapted from OpenFisca. So if we look at, for example, PolicyEngine US, essentially these are broken down into a few different folders. So here's the core Python package. Data is where all the microdata processing happens. Parameters are all the numbers, so like that 30% expected contribution is in there. And variables is the logic that hooks it all together. And we do a lot of tests as well. Okay. So for example, if we go parameters within government, this is now the same kind of folder structure we saw to get to that 30%. So we can go USDA, SNAP, expected contribution, and 30%. And here's something we really try to do. It's not always possible, but we try to cite as many primary sources as possible. So in this case, this section of the legal code is where that 30% is defined. Okay, 30%. Okay. So, and at some point, we're going to put that into the actual app. So you can see as you're in that trend of the parameter graph, you can see where those numbers are coming from. And we also have a lot of documentation on using the software. So our UK is the most developed here. So we use Jupyter Book, which is a great way to publish Jupyter notebooks in as web pages. So you have all these different code snippets and the results, showing people how they might use that interface beyond the web app, but also all of the validation we do. Oh, this is embarrassing. Okay, here we go. This is a little bit less embarrassing. So yeah, basically all this whole table is generated every time we do a new update to the model, and it compares some of these core programs that we do the reweighting against between our model, external totals from the government, as well as UK Mod, which is the only other source that provides those kind of data. So we're able to say, if there are some ways in which UK Mod is more accurate than ours, we'll be fully transparent about that. This is part of our continuous integration process, where every time we make a change, it's running all these tests to make sure we don't break anything, except sometimes documentation, I guess. And but also publish these aggregates based on the latest model. There's an actual graph here. Okay. Reweighting. Yeah, so here's also where we show how, as we reweight using gradient descent, our model loss becomes a lot smaller. So we become a lot more accurate. Okay. Okay, this didn't work. I think I was supposed to do l.append. Alas, next time. Okay, so that's the end of the demo and tutorial. Just wanted to close by talking about some of the other projects we use that are valuable as we develop our software. So certainly, we use open source everything. Python, React, TensorFlow is what we use for doing all the gradient descent and machine learning based reweighting. OpenFisca has been enormously valuable. Jupyter Book. So all of the work that we're doing is really built on the shoulders of giants, as they say. We have all of our open source software. So actually I need to update this slide. Whoops. We used to name things PolicyEngine, but we also have other software that we release that's independent of the PolicyEngine software for anyone to use. So for example, all of our data management. We use GitHub as much as we can. So GitHub Actions has been very helpful for automating our tests as well. And we use methodologies like test-driven development. We didn't really show how our tests work, but basically we have thousands of these different individual cases that are all in the GitHub repository as well that show here's what we expect to happen from this computation or this specific part of the computation tree. So we write our tests first every time we're developing a new feature, and then we write the code to satisfy the test so that ensures we're not sort of biased by the implementation we've already defined. And reflecting about where we could go from here, I think there's a lot more economics we could do in terms of transparency. So for example, the CBO, when they do their models, to some degree, it differs from other models because they have different structural model. They might have different tests or raw data. They might be modeling programs slightly differently. But also there's all these elasticities that they're transparent about changing or about defining. So JCT has a different labor supply elasticity than CBO. So what if you could just isolate those changes to the structural parts or to the parametric parts? So use the JCT elasticity with the CBO model, all that kind of stuff. So they're defining the structure where we are, or we're all sort of working together on a common structure, and then people are just disagreeing about those parameters, but it's transparent. I think that would be really great. More outcomes like carbon emissions, race and ethnicity inequality, those kind of things we'd love to get in. Program take up. This I think is a hard one, but really important. You have some benefit programs that have something like 80% take-up rate, some benefit programs that have more like 10% take-up rate. And there might be some ways to model if you're introducing a new policy. I mean, CBO does this to some degree, but what are the characteristics of that program that are going to influence how likely people are to actually participate in the program? And you could adjust that and put it into the model. Also dynamic macro modeling. So I know Rick Evans is on this call. He's an expert in pairing microdata with macroeconomic overlapping generations models. So we would love to bring that into our model as well. Data. So all the integration of the microdata sets, we're actually just in the process now of building a more unified framework that makes that a little bit more transparent, has more diagnostics about how to do that with machine learning, and same thing with reweighting. So all of those, I sort of show that epics curve that shows how our accuracy improves as we develop the model more. We'd like to make that fully available to others. And then things like accuracy. Ultimately, microsimulation models are predictive models. So could we do uncertainty modeling and backtesting? And this is kind of typically out of the scope of a lot of these models, but it shouldn't be. So I'm really excited by the developments in forecasting platforms, prediction platforms like Metaculus and manifold markets. So maybe there's some way to hook in some of these predictive models based on policy reforms into those. And communication. I mean, I really think these LLMs are a game changer. Like last week, I'm not sure if I felt even half as excited as I do today, just because it's been so easy for us to bring those into our software. And it can make information accessible in all these new ways. You can really target the information so people understand. Oh yes, thank you, Grace. The prediction platform for the social sciences is a fantastic resource, and I really hope it grows. So yeah, LLMs, you'll be able to say, here are the policy impacts for you in plain English, not just a table or a chart. Help people navigate these cliffs in different ways or understand the implications of different choices that they might make in terms of labor supply or anything else. But also, of course, it's a risk because it is not transparent in some ways. We don't know how these LLMs are working behind the scenes. So we've tried to add caution to that by making the prompts as transparent as possible. I think I'm not sure we'd have a reason not to always show the prompt in the app itself so that people can adjust it and see how it changes. And of course, all of our prompts are on GitHub as well. So if people have feedback on that, we are eager to hear it. All right, that's everything. So thank you so much for the time and for your participation. And I look forward to your questions.
Thank you very much, Max. That was a very exciting talk, and yeah, it's always great to learn more about the great work that you and others are doing. And I'll just take the first question, and then I'll open up for the floor. But I was wondering if you could do the exercise of like pretending that you are an analyst at the Congressional Budget Office or here in California, the Legislative Analyst Office, and they wanna so like you wanna learn how were the rules implemented, how are the benefits assigned in detail, but you don't use Python, you probably maybe use Data or Excel or something like that. How would you guide them into like inspecting sort of like the details of your model?
Of our model or their model? Okay.
Your model, yeah. What's behind the policy engine?
I think the UI, especially the earnings chart, I think helps ground people. Like if you're at the CBO working on taxes, you know what trapezoid is with all the tax credits. So if you can see that for an individual, see how it varies for different ones, and then sort of as I showed today, you aggregate from there. So sort of build trust with the individual component of a policy rule, and then build trust with the accuracy of the data, which I think ultimately CBO probably excels at because they have all this private data, but we can at least show them the comparisons between ours and what they do. And we're trying to do that more. We're actually about to publish a post on Biden's proposal in the budget to raise the top marginal rate from 37 to 39.6%. And we are way under, we're like 2/3 under what the JCT says. And we know that is because the CPS top codes income, but we're putting it out there so that people see front and center what the limitations of our model are.
Great, and if people have questions, I see Rick Evans has a comment. If you want to expand, Rick.
It was just really a compliment of the functionality that Max and Nikhil have developed, and I've watched them do this over the last 3 or 4 years, and the speed and the rates at which they've created this stuff. I just think this is the right architecture. It's the most user-friendly that I've seen in just the Python code, and yeah, just high compliments.
Thank you, Rick. Appreciate that.
You see, in the ideal world, in your wildest dreams, like in 5 years, how would you like to see, how Policy Engine has developed, how it's being used? Like if you could, like cast some vision. This is super interesting to me. I'm very new to this, this field, but would love to hear from your perspective as someone who's worked on it. Like, what is like the dream use for this?
Yeah, again, I think like 2 weeks ago, I would have said, man, in 5 years, if we could automatically parse legislation or tweets for people who are making policy proposals and automatically compute the impact, like that would be unbelievable. But Nikhil, my co-founder and CTO, he basically built like the seeds of that this morning. So LLMs are just, it's really hard to even think 5 years out. I think, there are institutional things that are inherently going to be slower. Like I would love it if our rules engine could power the actual benefit offices, right? So I was talking with a woman who is low income and very familiar with the tax and benefit system. And she has a child who has a disability, and she lives in Florida. She was pretty sure that she's getting the wrong amount from SNAP compared to what her mega spreadsheet said. So she asked them for the code, and they said they could provide it, but it would cost them $3,000 to provide the code for this benefit rule. So if you had a single open, there's tons of parts of that system that don't need to be open source, and like companies need to make a profit selling case management software or whatever. But the rules itself, those are just an expression of the laws. So if it was the same open source model that powered that and powered policy analysis and powered tax analysis, and maybe even IRS rules at some point, and it's the same framework that people all over the world in lots of different countries are using to quickly see what the impact of every policy reform. You can get notifications about if you are that low-income parent who benefits from SNAP. Every time someone proposes a new SNAP reform, you could see how it affects you instantly. That would be, I think, pretty cool.
Expanding a little bit on that it's like a 5-year horizon or very long-term horizon, and the and also following on the compliment that Rick was giving you, that why not aspire to like have a unified place, being this microsimulation model or a repository that contains all these rules of assignment of benefits, and basically not have multiple agencies, multiple think tanks, multiple analysts develop their own, and hence opening up the space for subjectivity, for researcher degrees of freedom, for many things. So I would encourage you to think of why not start thinking of pushing JCT or CBO or others of we should all have the same default. Maybe people have access to different data, maybe people have access to different I think data should be the main differentiator, but rules and without getting to I don't know, behavioral responses, when it's just rule-based, we could aspire to have just one common starting ground, and this could be that common starting ground.
I agree. I didn't want to say I want to eat the world in 5 years, but I mean, that would be cool. Yeah, eat JCT and CBO, that would be cool. But yeah, seriously, I do think CBO still is, there's so much to provide, and there's so many policies and ways to enhance the accuracy. Uncertainty, I think, is a really hard problem. So if we can solve some of these problems with a unified rules engine, and then every organization, maybe they have different models, not just of the point estimates, but the uncertainties. There's plenty of work for CBO to do, especially at the state level. There's just really, I think, very underdeveloped modeling architecture for understanding the impacts of those. So yeah, I agree completely.
So hi, Max. I feel like this is a very great platform, and I think the tax calculation platform here is really brilliant idea, and helps a lot of people to to try to calculate their own tax. I do have a question. What's the average the users we have in this our website, and what kind of the ways to promote our website, our platform to to let more people to try to use that.
Yeah, right now, I think you saw I think we've developed it a fair amount, but it's still kind of confusing. And there's a lot of information on the site. So I think as a result of that, our users tend to be the policy wonk kind of audience, folks in think tanks, or even just enthusiasts, sort of Twitter, econ folks. And we do have users for API that are bigger institutions that are using it for their own software. And in the UK, we've actually had a lot of more uptake from the bigger think tanks that are thinking of using it, as well as the Green Party, for instance. And The tougher nut to crack is how to get this information to households themselves and people who have less policy fluency. I really do think that LLMs could help there. We tried just amending our prompt to say, explain it like I'm 5. And it did a really good job for explaining the impact of policy reform. So, but it still has to, there's a lot of UX work that has to go into just making it work better there too.
Awesome. Thanks a lot.
Yeah.
If there are no other questions for now, I just want to say thank you again to Max, and thank you to all of our participants who are joining today. Thank you to Templeton World Charity Fund for supporting this. If you want to go over some of the topics that we covered today, we will be posting the slides and recording for people to go at their own pace and maybe try to do more hands-on activities by themselves. I do want to remind everyone that our next session will be on April 6th, and we'll be sending out reminders for that through our newsletter, as well as our social media platforms, the Bits and Sega Twitter. So please subscribe and follow along so you can keep up with all of our updates. And I think, yeah, that's all that I have. Thank you so much, Max. And, we'll provide all the materials to participants afterwards.
Thank you for hosting this, and thank you all.